All right, welcome to Math 121, Brave New World of Remote Education. So this is all brand new. We don't know how this is going to go. We're just going to try to go through the lessons as quickly as possible. I want you to watch the lessons. I'll post them as we go through the semester. And then the class time, our regular class time, I will have a Zoom account where people can log in and ask questions about the homework, but ideally you will have watched the lesson before that so that your questions are ready for that class time. All right, so this is college algebra. Math 121. And chapter 1 today is I'm going to try to do it in just sections, 10 or 15 minute lessons on each section. So today, this first lesson, this first 10-15 minute video will cover sections 1.1 and 1.2. And all the information about the book and everything else is on the syllabus that's posted on D2L. All the information you need is on D2L, so please make sure you look at the syllabus. If you need a book, you absolutely need a book to pass this class. Reading the book is 90% of learning this material. Okay? So anyway, section 1.1 in the book. Now also there is a prerequisite section that you should look through. That's chapter P in the book. And we're not covering chapter P in the book. That's something you need to look through and make sure that you understand that material. These are things like properties of exponents, properties of radicals, properties of rationals, all these things that you are required, not just suggested, but required to know before you start this class. If you try to start this class without knowing those things, it's going to lead to difficulty. All right, so 1.1, very quick section. We're just dealing with coordinate systems, plotting points on those coordinate systems. We'll just list what we'll cover and then we'll briefly explain each thing. Plotting points and equations, reading a graph, and let's see, intercepts, x and y intercepts. So that's what we want to discuss here in section 1.1. All right, so coordinate system, let's see, is this good over here or should I go over there?
Let's go.
All right, so hopefully coming into a college math class, we've all seen this two-dimensional coordinate system. Right? We call this the Cartesian coordinate system, right? Cartesian coordinate system. X values are called independent variables. Sometimes I guess we'll leave that for when we talk about functions. But let's just look at the points here. This point where the x and y axis cross is the point 0, 0, and that is called the origin of this Cartesian coordinate system. The y values go plus above the x-axis, negative below. The x values go positive to the right and negative to the left. These lines go to infinity in all directions. So we have positive x values here and positive y values here. So what we call an ordered pair of coordinates. A coordinate is an x value and a y value. An ordered pair or a pair of coordinates is called an ordered pair. In this, we call this, notice we have 4 kind of quadrants. We call these quadrants. We call this quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And notice in quadrant 1 we're going to have positive x values, positive y values, the x and the y. In quadrant 2 we're going to have negative x values and positive y values. In quadrant 3 we're going to have negative x's and negative y's. And in quadrant 4 we're going to have positive x's and negative y's. And please catch any mistakes I made. But you know what you're doing here also. All right, so again, hopefully you've all seen this before. We want to be able to just know what this system is. We're going to use this a lot. This is a two-dimensional system. It's a flat world. If you've ever seen Flatland, it's a good movie. But everything in here is two-dimensional, right? It doesn't go further into the board or come out. We're just talking about length and width. So we have a two-dimensional system where we explain a lot of what we do in algebra. Plotting points and equations on this system is something we want to be able to do. Let's go over here. Is there any glare over here? Should I close these?
Yeah, probably. Yeah, that's enough.
The rest of them? You can stop it while we're doing this. If we're asked to plot a point, again, I'm just going to quickly go through this. I think we've all seen this before. If we want to plot the point, let's say -3, +4. We go -3 on the x-axis. We go +4 on the y-axis. We meet those up and we plot the point -3, +4. Okay, I think we all have seen this before, plotting a point. Another thing we want to do on these coordinate systems is plot or draw an equation described in x and y variables. So let's get rid of this and look at an equation involving x and y. So if you're asked to graph this equation, okay, so we've talked about the coordinate system, we plotted a point. If we want to graph an equation, plot an equation, graph an equation, what we're going to do is set up a little xy table. Many times the x value is called the independent variable because we choose what it is, and the y variable is called the dependent variable because it depends on our choice of x. Okay, so here we choose some x's and we see what y's are given. And generally we start about the origin, the x is 0. Maybe we go out to x equals 1 and 2, -1, -2, just to get an idea of what the graph looks like, and then we connect the dots. Okay, so if we choose x equals 0 and put 0 in for x, we see y is 0 + 3, and we get the point 0, 3. Right, so we can now plot the point 0, 3 up here, label it as the point 0, 3. If we choose x equals 1, we put 1 in here, we get 1 + 3, and we see that y equals 4. So if we go out to x equals 1, we come up here to y equals 4, and we get the point 1, 4. Let's put this over here, make it a little clearer. And if we notice that x and y both have an exponent of 1 on them, exponents again, prerequisites, if we have exponents of 1, we know it's a straight line just going through those 2 points. So we draw a straight line, we put arrows through it, and we get the equation graphed. So this is this equation graphed on our two-dimensional coordinate system. All right, so those are the things we want to do. You want to take away from 1.1, you want to be familiar with the coordinate system, you want to be able to plot points and equations, you want to be able to read a graph. So reading a graph, let's look at something here. All right, so reading a graph is just being able to look at a graph that's given. Let's say you're given this graph here, and you're told this is age on this axis and height on this axis. And let's go from age 5 to 15. And generally, if we take the height of a 5-year-old, let's say, what's a 5-year-old, maybe 3 feet tall? And then we take the height of a 15-year-old, and let's say he's a 6-footer. And we're asked, and then we have ages in between here, all between, and we have some different points describing the height of a 6-year-old, a 7-year-old, an 8-year-old, and so forth. Let's just make it 1 point for each age. And if you're asked a question, let's say, what height is the 15-year-old in this type of setting? So all you're doing is saying, okay, this is age on this axis, this is height on this axis. The question is what height is associated with an x value. Call these x values. If we like, call these y values. Doesn't really matter what the letters are. We use whatever letters we like. X and y are usually the most common. So all we're saying here is what height goes with a x of 15. So we go to the x of 15. We see the height is over here at 6 feet, so the answer is 6 feet. Now this can be asked either way, right? So here the question gave you an x value and asked for the y. The question can also be put the other way. What age is the person with a height of, oh, let's say this one here, looks like about 5 feet. So we'll say what age is the person with a height of 5 feet? So now instead of looking at the x and finding the y, like we did for this one, now we're looking at the y value associated with 5 feet and looking for the x that's associated with that. So if we look at these as 2, let's say 7, 9, 11, and 13 here, we can say it's the 11-year-old that's 5 feet. So that's reading a graph. Okay, reading it in either direction. Given an x value, be able to find the y. Given a y value, be able to find the x. And the last thing in this section are intercepts. And intercepts are just simply where the points or where the graph crosses the x or y axes. So this is pretty simple. If we have some sort of graph that looks like this, this would be an x-intercept, this would be an x-intercept, this would be a y-intercept. And these are x-intercepts here and here. So if you're asked to find the x-intercepts, all you're doing is looking for the points that cross the x-axis. If you're looking for the y-intercept, you're looking for the point where it crosses the y-intercept. Did I get a new marker? Okay. All right, welcome back. This is chapter 1.2, dealing with linear equations, and I believe